In this video, I want to go over the flowchart and the results for the study by Link et al. And we'll begin, as we often do, at the bottom. And typically, at the bottom, when we had a binary variable, we'd have y indexed by I, and y would be a 1 or a 0, depending upon whether the outcome was a success or failure. In this case, we're going to have just the letter B without any indexing. It's also going to have possible values of 1 or 0, and B stands for breeding. And the value of B will take on a number of 1 if the bird successfully bred, 0 if it did not, and these 1s and 0s are going to come from a Bernoulli distribution with parameter theta. B stands for breeding. So how do we get theta B? We get theta B by saying that the logit of theta B is going to be equal to this function. And then once we got the logit, we can back calculate using what we saw before, which is this idea of e, the f of x, or 1 raised to the f of x. When I look at the components on the right-hand side, what I see is two different fonts. One font for the coefficient, another font for the variables. Let's look at these. So U beta is just the intercept. We've got the age of the bird. So upon hatching, the birds were marked, so we know the age of each bird. There are 12 different years. So whereas age would be a continuous variable, year would be discrete. And then we've got bird, which is going to take on 845 different values because we've got 845 different birds. So if you think about what these coefficients represent, those affect the slopes of the linear and quadratic. This is the effect of the 12 different years. And this alpha beta, this is really important because we can think of alpha beta as representing the breeding ability of the bird. And perhaps a way to look at this is it's very much analogous to what we saw earlier when we had the batting ability of a baseball player. So now we've got 845 breeding abilities as opposed to 948 batting abilities. But the idea is that they're both very similar in the sense that they can be thought of as latent variables, things that we believe exist, but which cannot be directly observed. So that's this side. Then we come over to this side and we see something similar, except now we've got S. And S can be a 1 or a 0, but whereas B stood for breeding, S stands for survival. And so the idea is, does the bird survive or fail to survive in any given year? 1 or a 0 arising from a Bernoulli distribution with parameter theta S. The logit of theta S is shown here. Very similar formula. The only difference is between here and here is that there's no quadratic effect of age. So everything we've seen up until this point can all be thought of as the likelihood function. So everything we've seen so far is just the likelihood function. Now what I want to do is think about the priors. So this one, 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 they're all going to need their priors. And so for mu phi, we might specify a prior as being very flat prior. Let's give it a mean of 0, a very low precision 0.001. these two, alpha beta reflecting the breeding ability and survival ability, they're going to be different. Whereas up here, we specified the parameters in the distribution. For these two, we're going to name the parameters in the distribution, but we're going to have JAGs come up with the posterior distribution of those parameters. So we're going to think about alpha beta, the breeding ability, alpha phi, survival ability. We can consider those things together because each one of the individual birds is going to have a pair of values, alpha phi and alpha beta. We consider that pair to be alpha bird, and we can consider those values, those pairs, to be drawn from a multivariate normal distribution, in fact, a bivariate distribution with parameters mu and sigma. So what's mu? Mu is going to have its parameter, the overall mean of the alpha phis, the overall mean of the alpha betas, and the covariance matrix is going to have C1, which is the variance of the breeding ability, C2, the variance of the survival ability, and rho, the correlation between the two. And this is really the target. This is what we're really focused on, is rho, because we want to see if there's a correlation between the ability to breed and the ability to survive. So graphically, what we see here is represented by this. So the prior for alpha phi and alpha beta is going to look like this. It's a bivariate normal distribution with two means, alpha phi and alpha beta, and then a covariance matrix that captures the shape of this thing. So that's going to be the model. So we run this model, and again, the primary focus is on rho. This correlation between survival ability and breeding ability, and here we have breeding ability shown here, survival ability shown here, and we get a positive correlation. And that wasn't necessarily what the authors thought would happen a priori. The authors thought a priori that it's possible that there would be a negative correlation in the sense that those individual birds who are really good at breeding would be so exhausted by the experience they wouldn't be able to survive. But in fact, that was not the case. They were also able to look at something else. Here we have a plot that shows what's referred to as individual means. So if we take each one of those 845 individual birds and we look at the probability of them surviving as they become older, we see that the probability of survival goes down. That's what we see here. On the other hand, we've also got this other plot called population mean that stays relatively flat. Now, my understanding of this population mean is what they've done is they've taken these individual cohorts that ended the study at any particular time and tracked them as those cohorts became older and found that there wasn't a decline. Now, why would that happen? Well, first of all, think about what this lack of decline means. It means that we started off with 100 birds and 20% died, then we'd be left with 80 birds, and next year another 20% died, there'd be 64, and in the next year, if another 20% died, there'd be 51.2%. So you get this constant 20% attrition rate over time. And the author speculated that there might be two things that are happening pushing that relationship in opposite directions. So the one thing would be that if we consider the individual means of the birds themselves are becoming less vigorous. On the other hand, if you think what happens as we transition from one year to another year, the individual birds that survive from one year are the most vigorous. So in a sense, although the vitality of individual birds is going down, because the weakest birds are successively being picked off, those two things work in opposite directions to give a constant decline in population mean over time. in any event, this is just what I consider to be a very nice example that shows the power in using beta and data analysis to get at things like individual means and to get at things like rho, which otherwise would be quite difficult to get if we merely used frequentist analysis.